Hey students, it's Mr. Bornheimer, and get ready, caution. We are about to talk about scientific notation. For those of you in my classes, we've been talking about scientific notation for a while now, and some of you've picked up on it quite fine. Some of you might still struggle with it a little bit, so today I wanted to do a quick short video on some scientific notation concepts. For those of you, this video will only be probably less than 10 minutes, so you can watch it quickly if you need any help or anything like that. So let's start with a couple of examples this morning on scientific notation. So we're just going to go ahead and get started here. Let's say we start with the number 0.003462. Okay, now the very first thing we need to recognize is that in scientific notation, this doesn't work. Okay, we need to move the decimal. And scientific notation oftentimes always is about moving the decimal, getting it in the right spot so that the number reads correctly. In this case, we would move the decimal 1, 2, 3 by doing the loop-de-loop-de-loop-de-loop-de-loop. Okay, so we move it 3 spots, okay, 3 loops, and we end up with a number that's 3.462. However, this is not the same number we started with, so to compensate for the fact that we moved the decimal and to keep the value of the number exactly the same, we add a times 10 raised to a power. However, we have to decide what that power is. Now, one of the things I like to remember is that if my number started out being less than 1 as a decimal, then I'm going to end up with a negative exponent. So in this case, it's going to be negative, and then however many loops I had. In this case, I moved the decimal 3 spots, so it's a negative 3. And this would be scientific notation. These two numbers are exactly the same. However, this one's in scientific notation, and this one is in just decimal notation. The difference being that in scientific notation, we have this times 10 to the negative third, and it allows us actually to multiply, divide, add, and subtract these numbers easily. It also allows us to write very large and very small numbers more easily as well. If we had to write out this number every time, it'd be a little cumbersome. However, by writing it in scientific notation, it gives us some distinct advantages, especially when we're doing lots of calculations. All right, let's look at another example. Here we go, example number 2. We have 12.64, okay, so 12.64. This one also is not in scientific notation. If you recall from some of your, maybe from previous classes, scientific notation allows you to have one digit and only one digit that's not a 0 to the left of the decimal. So in this particular case, this one needs to move to the right, or to the left, excuse me, 1 spot. So it becomes 1.264 times 10. Okay, now my number was larger, okay, than 1. And I moved the decimal 1 place to the left, okay? So in doing so, what I'm seeing here is that I actually want to be able to put the decimal here. So if I were to multiply this by 10, it would actually become 12.64. So I don't really want to change the 10, but I still need the exponent. So I'm going to go ahead and put a 1 here, and then I'm done. Okay, let's look at another example. This one is 4,560,000. Okay, here's the number. These are not decimals, they're commas. What we're going to do is we have to recognize that here there is a decimal, it's just hidden. So we have to know where the decimal is, and it is actually here at the end of the number. And we need to move it so that there's only one digit number to the left of the decimal. Right now there are 7. So we're going to go ahead and move it 1, 2, 3, 4, 5, 6 spots, and it becomes 4.56 times 10. Now my number was very large to begin with. So what I'm going to need to do is I'm going to need to go ahead and put a very large exponent here, and in this case it's a 6. Okay. Okay, students, we're going to talk about a few more things with scientific notation here, and that is, okay, when you have scientific notation, remember that the number that you're working with is always going to go to the left of the decimal. Okay, when we move all of these numbers over, okay, they represent the value of the exponent that we're going to be using. If you look at this example, you start with this blue number here, and you see that if I move the decimal 1 to the right, okay, it places this 2 to the left of the decimal, and that is important. We compensate by adding this 10 and this -1. Now I moved it to the right, and in doing so, I took a number that was in decimal notation, and I put it in scientific notation. Now the number started out being less than 1, so it's going to be a negative exponent. The general rule of thumb is that when you move the decimal to the left, your exponents will increase in size. So in this particular case, I had 45 times 10 squared. I moved the decimal to the left to put it into scientific notation. In doing so, I raised the exponent to a 3. Had I moved the decimal to the right, had I needed to move the decimal to the right, I would have reduced the exponent, so it would have gone from a 2 to a 1. Algebraically, the reason we can do this is 45 is really the same thing as 4.5 times 10 to the first. If I were to substitute that back in and then multiply by the 10 squared, because it's really just an algebraic expression, I see that I can use some exponent rules here. I have the exponents of 1 and 2, and because the bases, the tens, are the same, I can add the exponents, and they become a 3. And this 4.5 times 10 to the third is exactly what we got here by using our rules for scientific notation. Okay, so this is scientific notation. If you have any questions, you can contact me, or you can see me outside of school. Otherwise, I hope you have a great day. Thanks for watching.